it's unfair. Almost unfair.
Let's see. I mean, there's Verstappen, so let's see what happens.
I don't know if it'll be good teammates though. I feel like they both won.
Really not going like good team interaction, but I mean, Verstappen is really good, so let's see what happens.
Also, Piastri might be better than Lando this year too.
Yeah, I hope not, but yeah, could happen.
You like Lando more?
Yeah.
Yeah.
I don't like Piastri. I don't know. He has his attitude every time that he won. He's like, yeah.
Yeah.
Not a big fan. Yeah. I used to like hate Verstappen,
Yeah.
but now he began like losing, right? So like, yeah, maybe
Yeah, you don't care.
give it a chance.
You can be mad all you
All right, I think we are recording. All right. Yeah. All right, so today's lecture is going to be about these I mean, you've probably seen something. Give it a minute. I'm just gonna wait for the data show to present something to us. All right. So this lecture is going to be focused very much on this idea of argument passing. And based on what we have already discussed, we are going to make some sort of analysis. The way that I am going to go about trying to show you how argument passing works is, of course, via examples. And we're going to see that we have these different ways in which Java would consider the argument parsing. So let's begin with first example, and also maybe quickly introduce this idea of pass by copy or pass by value that you might have heard about, might not have heard about. So let me go and say what that means, right? So when you have some kind of procedure that is called in your program, right? So you have a statement, you have a line that invokes, for instance, a method. There is like an instance method in a class in Java, for instance. One of the ways that your stack and your JVM could go is it could copy the arguments that you are specifying. So of course, assume that the method would take some kind of parameters, right? So imagine that you have one parameter being passed every time that you invoke that method. So when you write that statement and you put, let's say, a literal, like an integer, one way that we could go about it is to really just have that value copied. So I would do a memory copy operation, and then, of course, the copy would be the thing that would be received by the scope of the execution of that method, right? So you have a difference between the value from the context where it was called from, the invocation context, and you have the actual execution environment that's going to be those two main contexts, and not necessarily going to have the same memory location, right? So that's essentially what we typically call pass by value or pass by copy, depending on the place where you're reading that idea, that concept from, right? Let's see one first example where we try to explore that idea, right? So I have here a class called argument. I have a field that is a primitive integer called value. I'm setting that as -1. Then I have a method that is a instance method called change value, doesn't return anything, does receive a value here that I'm calling arg, and then that is going to be typed as argument, right? And what I'm doing here is just going and changing the value of that arg that I received, and I'm just going with the plus equals. That means that I am picking up the value that it was before and just incrementing by 1, right? So if it was like 10, then it's going to become 11, and it's going to be assigned to the new value is going to be assigned to the variable. So if I take a look at the main method here, right? So I am going to, for instance, create a variable. I go with that type that we have just declared here. I create one instance of that type, then I print that value from my variable here, right? And then I call the method, right? The change value method, and then I go and I repeat the process, right? So I just go in and do precisely the same thing, right? Then I go again and print that value again. So in other words, what I'm trying to say here, set up this kind of experiment where I create this variable some way. In this way, is really just calling the default constructor. Then when I go and print that value, I would expect to see a given value, right? So nothing really have changed, so I would not expect to see any change. But then if I call that method, right, then what's going to happen is that I would actually need to, perhaps I would think, if I pass that reference of that variable, right, does that mean that I would be operating on that or not? So in essence, we want to see if that's really the case, right? So if the idea of pass by copy would be, let's say, trivially implemented in Java, then I would be operating on some kind of copy. So then if I am calling that test from my main method, I would most likely expect the change to not having any modification from this context, right? From the main context. So hopefully that's kind of set up that we have makes sense, right? If you actually run that, right? So that's what we do here. You would see that these would be the kind of outputs that you would be getting. I don't. Can you guys read that size? Yeah. So these would be the output, the actual output that you would be getting if I run that program, right? So in other words, you see that obviously that value changed. So that kind of contradicts what I just said in terms of this idea of copying, right? So if I copy and I modify the copy, so then how comes I go back to the main method and then I check the value and it is changed, right? So what really happened, right? It looks like we have a little bit of a problem here in terms of what I just said and what I just have shown you as an example, right? Because what I just said would most likely lead to our belief to have that output not change. But then if I run that code, and you can try to run that code, you would see that that's actually, there's going to be actually a change, right? All right, so let's state sort of the main goals that we have here for today. So first, we want to identify whether the arguments that we're going to be using would be of a certain kind. And by kind, I'm going to create this category of things, category of arguments possible being as a primitive, an array, an object, or a string, right? So then we're going to make our analysis mainly based on these 4 kinds of arguments that I should be passing, should be receiving from the perspective of the method execution, right? Then the next thing that I also want to see is if we would be able to predict what the outcome would be, of course, based on the kind of argument, right? So I would expect, depending on the kind, depending on the ability to identify what that kind be, I would expect a given outcome to be predictable, right? So for instance, I would expect to be able to tell that that change would actually happen, or if that change would actually not happen, right? As in the example that we just saw, okay? Hopefully that makes sense. So let's go and one more time rephrase kind of what I already mentioned at the beginning here, but nonetheless, let's go over it. So we have this idea of scopes that we have talked about before, and it's kind of intuitive to think that because we have these calling procedures, every time that you call, let's say, a method, and you enter the execution of a method, you are in a different context, right? So So it's like that idea of a call stack, where every time that you make a call on some kind of procedure, as soon as you enter the execution of that procedure, that means that you are creating a different execution point, a different element, a different position of execution in your stack. So that's why we typically call that idea a call stack, because every time that you call that instruction, every time that you call that procedure, every time that you call that method, so then you have that added, that execution environment, that scope added as one new thing that is going to be processed, that's going to be executed by the call stack. So this is taken care of by any high-level supervisor, any processor. There's even some hardware components involved in that, right? But from the perspective of our Java environment here, my JVM is going to be taking care of that. So my JVM has a built-in mechanism that would be, of course, having some part of memory storing those calls. That's going to be organized in a stack, and it is a stack, of course, because as soon as you process something, you want to get rid of that, and then the next thing that's going to be executed is just the thing that's previously called that procedure. So every time that I call a procedure, I put that on top of the execution, right? So that's executed. As soon as that finalizes, as soon as that completes, then that vanishes, and then I go back to the previous calling scope. So that's the main idea that in other words, allow us to differentiate between scopes, right? So if I am using the example that I have just gave you, if I am the main method and I call a class method, an instance method, then that means that I have an outer scope that is my main method, and I have an inner scope that is the scope that is the execution of the method, right? So again, as soon as I call the method, I enter the execution of that method, I am in a new scope now. That's going to be what I call that inner scope, right? And then we have these two concepts related to how we would expect our JVM to treat those values, those parameters, every time that I call a method that actually takes parameters, of course, right? So if I have a method that takes parameters, I have, in essence, these two main high-level ideas. One would be what I mentioned already, that is the idea of copying. So if I have, using the same example that I used before, if I have a primitive integer and I don't want to use that specific chunk of memory, I can just create a copy of that integer, and then in that inner scope, I can process based on that copy, right? Which is going to be, of course, independent of that outer scope, which means that if I go back to the outer scope, I would not see any change that happened in the inner scope. Okay, so that's the main idea of the copy. And then you have the idea of reference, which is just the idea of a pointer. So if I actually call that value using a pointer, so that means that I am now working with possibly the same position in memory on both scopes. So that means that even that modification happening inside my inner scope, I would possibly expect that change to be permanent with respect to the outer scope, right? So I call the method, my method executes, changes the value, right? So when I finish that method, leave the inner scope, I'm again at the outer scope, I would see that change reflected. And those would be related to these two ideas of how to pass the values, right? All right, let's just take a look at the example. That's the same example as I have shown you before, right? And this is just to show that my main method here would be my outer scope, and then my change value method. Here I have a one-liner, right? But of course, you probably can tell that these curly braces here define an implementation of a method. That's a full implementation of my method here, and that is going to be what I am going to call my inner scope. So far, so good? All right, so I mean, kind of what we have already mentioned before, these all kind of make sense, but then how would we actually explain what we saw at the beginning, right? So we saw at the beginning an example where it said that Java passed by copy, right? And I stand by that, but then how is it that we would expect that copy to reflect something that only happens in that inner scope, only related to that copy, right? But we actually saw that the outer scope actually reflect that change, right? So maybe you should panic, I don't know. I love that scene, by the way. That's just the best ever. Okay, so let's go and visit these four main kinds of argument passing that we have in Java, right? So the first one is going to be the use of primitives. Second one is going to be the use of arrays. Third one is going to be the objects. So it's going to be when you have instances of objects being used, right? And then finally, the fourth one is going to be a specific kind of object that is going to be the string, that we have mentioned that strings are objects, but they are, sorry, they are also kind of different than the typical object because they are what we call an immutable type. Well, so maybe because they're immutable, then maybe some consequences, maybe the way that Java is actually going to be working on those would be different. Let's see, right? Okay, so let's now visit some slight modifications of this program where we would be, of course, visiting each of those kinds, right? Here, the first one that I'm going to be visiting would be the primitives. So if I modify my program here, right, so I'm going to get rid of that field here that I had before. In my main program, I am creating a variable that is a primitive type, different than what we had before, right? And I am here directly setting that to -1, and in my change value method here, I also made a modification, right? Because now my kind of argument that I'm going to be receiving would be that primitive type. And then here, similar to what I did before, I'm going to just use the plus equals operator. That means that I'm going to just increment by 1 whichever value that I have assigned that in that argument, right? So for instance, if I have 0 here, the result of that is going to be that going to 1. If I have 10, that's going to be going to 11, and so on, right? So if I so the kind of setup that I have is pretty much the same as what I had before, right? So I am again just trying to see what happens from the outer context, right? From the outer scope here, if a change actually was a persisting change or not, right? Based on the code that we have here. So first here, I only set that variable to -1 and then directly print that. So I should see, of course, -1 as the first input, that first output, right? The first print line. Then I call that change value, right? So then I pass that value here. I go and update that here. And then when I come back here, one of two things could happen. I could either see that being modified or not, right? So if that would be the same thing that we saw before, I would see a change, right? I would see just a change in that value. And if that's not the case, then I would just see the same value being printed. So what do you guys think? You think no change? Who thinks no change? Who thinks change? Who doesn't want to commit and say anything? All right. So in that case, you will actually not see a change with that argument that you have passed, right? So in that sense, maybe that's a relief, because then that would be one example where our first definition of pass by copy actually makes sense, right? Because if that would be a pass by copy, then that would mean that the value that we have operated on in the inner scope was just a value that is not really the same position in memory with respect to what I have in my outer scope, right? Because in my inner scope, I did make some kind of modification, right, with that call here, right? So if that does not persist, that's an indication that whatever I got when I entered the execution of that method was really operating on a copy of what I originally set in my outer scope. I guess that's good, right? All right, let's see what happens with an array. So again, I am modifying the code here, and now I am going to initialize my variable as an array of integers. And here I am setting that to be a 1-position array, and I'm going to set just that first element to be -1. Right? So this is just, if you don't recall, this is just the way that we would be initializing the array using the curly braces, right? And you can initialize with as many elements as you want, right? So that would be one of the ways that we can we can initialize the array. The other way would be, of course, using that square bracket syntax. Anyway, so you have that one element array initialized, and each element of that array is going to be an integer, right? So if I go and print, sorry, before that, let's take a look at the method here. So the change method was also modified to receive now an argument as an array, right? So the type has changed. And the implementation here also has slightly changed just to account for the fact that it's an array. So I go and access the element 0 of my array, and then same as before, I go and increment by 1. So the question here is same as before. Does that mean that this is going to be operating on a copy or not a copy? And then based on that, that should allow me to predict what happens, right? So finally, in the main method here, if I print that initially, I should see the same value that I have that I have set. So -1 is going to be printed here for sure, right? But then if I go and call that method, that change value method, then this implementation here is going to be run. Then now comes the question, the main question here, which is what would be the output? What is going to happen this time, right? Because so far we saw our initial example, and then we saw this example, the previous example with the primitive integer, and now this is another example because now we are going with the array, right? So would that mean that because Java is passed by copy, that same thing that we saw before with the integer would actually happen here? What do you guys think? Do you think the change would not happen, or do you think it would happen? So who thinks the change would happen? So who thinks the change would not happen? Okay, let's see. So you guys are actually correct, for most of you, at least. In that case, you would see that the change did happen, right? So maybe with these examples, you're getting more and more confused. Hopefully not, but that's still one thing that we need to go over. So there's one more kind of, actually two more, sorry, kind of arguments that we should explore, right? The first one being the object. So this is actually the very first example that we went over. So the very first example that I present to you would be the same idea that what you have here, right? So I don't need to, I guess, go over it one more time. Just need to take a look at the implementation here, where arg stands for an instance of that object argument, and then I access a field of arg, and then I just call +=1 on that argument, and then I would, same as before, I would check what happens with respect to the initial value that I set, right? So the first print line just shows me the initialization value because nothing really happened in terms of possibly modifying that. But then I call the method, and then I want to understand if a change actually happened or not. And you already actually saw the output, right? So as you see in this case, a change would actually be happening. Okay, that's the first example that we saw. Okay, any questions? All right, so last kind of argument that we have here would be the string type. So with the string, I will, kind of similar to what we had before, receive an argument as a string, and then here in my implementation, I would use that concatenation operator plus. So here I'm just appending a string to the current value of my string, right? And then of course, the result of that concatenation is going to be assigned to that argument, okay? So in that case, we are initializing our variable in a similar fashion to what we did before with the object. By the way, a string is an object, right? So it's a sort of a similar type, a similar kind. But let's see if that means that we will see the same possible output, right? So here, again, one more time, really running tired of seeing the same kind of thing, right? But that's the last one, so it's a good. I print that value initially, right? Initially, the value is going to be set here as original, as you see. Okay, first line of main, and then I call the method, and then I call print line again on that, and then I need to ask myself if I would see the same thing unchanged, or if I would see a new one, right? So what do you think? In that case, do you think a change would happen? Do you think a change would not happen? Okay. Oh, this kind of, I think about the same number of you are predicting both ways, right? Let's see. In that case, what happens? Do you see? Why? Right. So if you, of course, you guess wrong. If you guess right, you might have already got the idea. All right. So if you're completely confused at this point, right? So that's where I'm gonna try to make things easier for you. Yeah.
Out with respect to the object. So, not the object.
Oh, Priscilla?
Yeah.
Uh-huh.
So, if the value is, will it matter if the value variable is static or not in this case?
No, it would not. No, it would not affect anything. Yeah. So it's another way to say the thing here is not about the variable being static or non-static, right? The kind of prediction that I'm going to make here actually not need to rely on that. That doesn't give me valuable information. Okay. The main information actually I'm going to really be using would be just the kind of arguments. And if you just go with the kind, actually you would be able to predict what would happen, right? So based on the examples, actually, we could just try to replicate that, right? Based on the examples that you see. So we saw that with the array, right? We saw that the change was for persisting, and with the strings and with the object, we saw that the change was persisting as well, right? With the strings and the integer, we saw that that was not the case, right? So we have two cases where the change happened in the outer scope, and we have two cases where it did not. So if you just memorize that and go, actually, you would be able to predict, right? But you want to do a little bit better than that. We want to actually try to understand why those outcomes are coming out, right? Yeah, this is just a summary of what we saw, right? So from the outer context, if I would be using the primitive types or the strings, I would see no change. And if I would be using the arrays or the objects, I would see a change from the outer context, right? All right, so the way that we are going to make sense of what's going on is, guess what? Based on that idea that I already mentioned with you, that is the memory model, so the Java memory model. So we do have these sort of assumptions, these mechanisms that Java goes, and our understanding of how and where the values live in memory would be giving us the definitive answer and the intuition to understand why these things happens and sort of how, right? So here, this is a little bit more simplified than that idea that I have shown you with the heap memory and the stack memory. So here I'm not making any distinction between them, right? So the thing that I am trying to represent here is that you have these two different kinds of elements that you would need to store in memory, right? So one would be what we call the variables. So the variables would be essentially this idea that every time that you create a variable, that you declare an identifier, you would need to store that somehow, somewhere in memory, right? And initially, you can think that every time that you create a variable, you sort of have a pointer from that variable location in memory to another location that is where the value actually lives, right? So that would be what we call the data portion, okay? So this would be kind of related to the idea of the stack and the heap memory, if you remember that we talked about that in the very first lectures, right? But this is, of course, a little bit more simplified than that, okay? So you for now, you can think of like having these region where you have the data and that other region where you have the variables. And every time that you have a variable, then you have that sort of pointer that that reference. So being a little bit more specific, what I actually have here, if I inspect that memory, would be a sort of an address that would be giving me where that data lives, right? So that's how this pointer here actually exists in memory, right? That would just be a reference to another place in memory, okay? And by the way, this here is also not very precise because I don't think I have an updated, yeah. So this is not very precise because when you have a primitive type, if you recall, the primitive types would actually be stored in the stack, right? So that means that with the primitive types, I would actually not go with this idea of a reference, an arrow. So maybe it would make more sense for me to draw these slightly differently, depending on my variable being a primitive type or not, right? That's the first distinction that I want to make. If that's a primitive type, then the contents of the variable are just stored directly in that position, right? If that's not the case, if that's a reference type, which would be with the 3 other kinds of arguments, right? So if it is a string, if it is an object, if it is an array, all those 3 are reference types, right? So if I would have a reference type, then this arrow thing here, this pointer, actually does make a lot of sense, okay? Another thing that we can think is that, okay, if I am going to a memory location that is around here, right, and I access a field, right, and then I try to modify that field in an inner context, right, the memory location is the same both for the inner and the outer context, right? Because what we really mean and what we really should say about how Java works with the argument passing is that Java does pass by copy, but what it copies is a memory location. So if the copy is actually happening in a memory location, right, so that applies to the reference types, then I am just creating a copy of an address, of a memory address, right? So it is still a copy, right? But the memory address is just telling me where I need to go. So in other words, I am not really copying an instance of a class inside my inner scope, right? I'm just going to the same location in memory, but that happens with the different variable. So I create a different variable to represent that parameter, right? That is going to be different than the variable that existed before in the outer context. But both variables actually reference the same location as long as they are reference types, right? So as long as they are reference types, they would be referencing the same location. So my explanation of copy still holds, but then as I said, this is a copy of an address. This is a copy of a reference, okay? With the primitive types, it's a little bit different because with primitive types, kind of related to what we saw, not in this drawing, but the previous drawing that I've shown you, the values are stored directly next to the variable, right? The portion of memory that has information about the variables. So when I copy that, I am copying the variable along with the values. So I'm really copying the values, right? It's not the same idea as what we would be doing with the reference types. So I do copy the values. And if you remember, the very first example that I have shown you here, we had a primitive integer, and we did not really see any change, right? So the reason for that was because I modified a copy of that original variable. So I modified a different variable. So when I go back to the outer context, right, so my old variable is unchanged. That's why. With the array, you can think of the positions of the array in a similar fashion that you would think about the fields of a class, fields of an instance of a class, right? So it's the same as going to fields of a class. So I go to that region where that array lives. The array is also an instance, right? You go to the region in memory where that array lives, and when you try to access one position, this is the same as just accessing a member of a class, a member of an instance, sorry, right? So then I would be accessing the same region where the data lives. So if I make a modification, that persists in the calling context, in the outer context, right? Which would also happen with the object, where I try to do that with an instance, with a field, right? The last example is the string, right? So with the string, it's a slightly different story because with the string, I mentioned that strings are immutable, so that means that every time that you make any modification, you are creating a completely new instance, right? So if you think about that, if you are creating a completely a new instance, right? So that means that that variable that is a different inner scope variable that is a completely different variable as compared to the outer scope is going to be referencing when the result is generated a new instance of a string. So it's just going to dereference that original variable to another place in memory. Yeah.
Is that why the cost between like using a string builder and string concatenation is so wide for Java?
So the string builder is a way for you to be more efficient in terms of.
Why using concatenation is so much more costly than using string builders, because with concatenation we're just building more and more.
Yes, right.
Strings and instantiating over and over again.
Exactly, yeah. So under the hood, if you concatenate as we did in this example here, right? So imagine that you would have like 3 concatenations, right?
Yeah.
So that's especially costly when you have a series of concatenations, because every time that you operate two strings, you generate one new string, and then you go ahead and perform a new concatenation. So with that newly created string and another string, so then another one is created and so on. And every time that you create is a completely new instance of string. So there's a little bit of overhead every time that you create, of course, an instance of a class. With the string builder, what happens is that you are working on a more primitive level. So working on a character level, right? So you actually allocate an array in memory, and then every time that you try to append something, that just means that you copy that original set of characters to that array that you are operating on. And then at the end, you have that generated array of characters, and just say, okay, with that array of characters, I want to actually now finally create an instance of a string. And that's what the string builder does under the hood. Yeah. Make sense? Okay, so I guess I gave you all the information that you would need for us to go ahead and finally do a little bit of exercise, right? So now let's observe another series of examples where we would go and try to predict now what the outcome would be, right? And of course, you want to see if a change happens or not, okay? So here, I have an overloaded change value method here, right? Just to make it easier for us to make sense of the code. So of course, depending on the call here, one of those would be the one called, right? So you need to identify which one of those methods is actually the one that is going to be invoked, okay? All right, so here I am creating a variable of type object, and then object argument, and then I print a field of that variable, and then I call change value, and that change value is going to be mapping to that implementation, right? That overloaded method there, as you see. So that means that what kind of argument we are seeing here in this example out of the 4 kinds, right? So we have object, array, string, or primitive. Object, right? So this is an object, and do you remember what happens with an object? It changes, right? So it persists, and you would see that here, object type, and the output changes. So you guys are correct. Let's see the next example here. So what's the type now? So here I am using a variable that is an integer, setting that to -1, print that, and then call change value passing that variable. the type is going to be this one. Yeah, it's a primitive. It's a primitive type, yes. With a primitive type, will I see a change? No. Why? Because it creates a copy of the variable, and in that case, the primitive, the primitive variable lives along with the data associated with it. Now, the third example that we have here would be the variable being a string, right? So then the type is obviously a string. Here we call the method, and that's going to be the one overload the method that is going to be called, correct? In this case, will I see, so the type is obviously a string, right? And the question is, will I see a change? Nope, right? I will not see a change, right? Why? Yes, because the update that happens inside my method, right, was an update on a copy of a variable. So it's not the same variable that I have in the inner scope, right? So I did create a new string with the result of that concatenation, right? But that was assigned to a variable that is not the same variable that I have in the outer scope. Okay, that's why. All right, we have one more, right? The last one. The last one is going to be an array. That's the only one kind left that we have. So in that case here, this is going to be the one that is going to be called, right? So the type is array. And then what is going to be the output? Is there going to be a change or not? Change, right? There is going to be a change because for all purposes, you can think of the array as having a series of members, right, of the same type, right, in a contiguous fashion. So it's kind of what you would see in the fields of an instance of a class. Make sense? Any questions? Easy now? So it was, some of you was kind of looking a little bit desperate at the beginning, but hopefully now they're kind of get the idea, right? To be fair, I kind of pushed a little bit to be a little bit more interesting. I could have just come here and said straight away how you would be able to make the predictions, right? To give a little bit of emotion to the whole thing. All right, so we learned all that, right? So there's some code available. I think I put the code on the main repository. You can take a look and let me know if I didn't. I think I did. And just one last thing to leave you guys thinking, right? So I think I used to think that was like a universal truth, but now I don't know, maybe not. Yeah, if you can't explain it simply, then you don't probably understand well enough. Yeah.
So if we don't concatenate and we are just assigning a new string, it will still so outside this scope it will still be the same, right? It will still be the original thing.
But then how would you change the variable in the outer scope, in the inner scope?
So I'm just saying, like, if instead of doing the arg equals to new plus arg, instead we just did arg equals to new.
Even so, yeah, you could do arg equals new string, whatever. That would not change any. That would still, yeah, not affect the outer scope. Yeah.
What was a string builder instead? When you just print the string version of it, would it change?
Still not change. So this structure, right? Because like I have a variable in my outer scope, right? I have another variable that is initially it's a copy, right? Initially it's a copy of that original variable that I create. It's another variable, right? If I go and change either of those two, they're not like synchronized in any way, right? Initially they would be referencing the same object in memory, but then that can change, right? And that's what happened anytime that you change a string, because you cannot actually change a string directly. Just dereference it and reference another one, a new one. Mm-hmm. Still would not change. The output would not change. Yeah. And also the instance would not, like the instance of string would also not change because it is immutable, right? More generally, if that would be like an object, you could change the object, right? As we actually saw when we went and changed the field of an object. right? The fact that I cannot do that just because it's an immutable type. Okay, so if, for instance, if string would not be immutable, right? If there would be like a method that would allow me to change the same object, the same string object, so then you would see the modification, right? That's just not something that exists in Java.
String builder, if you try to change it, then also it creates a new reference.
A string builder is a different thing, right? String builder, you would be able to change the intermediate array of characters that you store. So you would be able to. It's string is not the same thing as string builder.
Following up on this question, standing the string builder and you're changing string builder in the
Then you would be changing. Then it would be the same as the object example that I have shown you here. Any more questions? Interesting lecture? All right, I'll see you next week.
Like, we expect
Oh, midterms are going to be week 6. Okay, midterm 1 is going to be week 6. This is week 4. So we have a little bit more than a week. Yeah, what I typically do is 1 week before, which is going to be next week, right? So I would come here and let's say, I need to check, but let's say I schedule the exam for Monday of week 6. Then I will just make sure that I let you know 1 week before that. So like this Monday. Okay.